fire up unit number 2 here, I'm not going to go crazy into the stuff at the top because, again, there's a lot of things we want to cover and a lot of things that are going to help us. But here's what you're going to find out with all of these things above if we were to work them all out. So I'm going to do the foiling for you. Because, again, we just would do our first. I'll do it on the first one. Our outer, our inner, and our last. Plain old FOIL stuff. Nothing fancy that we haven't seen. You know, we combine our like terms. Okay, that's cool. We get this kind of funky quadratic here. And if I had to go all the way through and do all of these, even though I forgot to change that to plus, that's a different issue. I do want to mention, because I've seen it happen now a couple of times on quizzes and homework, people coming up to me with it. This, okay, is not as simple as just distributing. That's not how this works. This means there is a second one of these. I'm even going to get rid of that, just so we don't get confused. Are there ways I could shortcut that? Yeah, and I'll show you. But otherwise, if I FOILed it back out again, I am going to have a middle term. That's why we can't just square it and call it good. For those of you that like to find patterns and shortcuts, again, I'm always available to be able to FOIL this out. I'm fine. That's good. But if you're looking for shortcuts, the way you can shortcut this is you square your first term. Okay, I got that. You square your last term. I got that. And then if you multiply these two terms together, 4x times negative 1 would be negative 4x, and double it, that'll get you your middle term every time. If you're looking for a fast way to FOIL out a quantity squared. Again, not necessary, but available. And so what we're going to find is with all of those, the highest exponent for each of those is 2, which is what a quadratic is. Something whose highest degree, or biggest exponent, is going to be 2. So we call those quadratic functions whenever x squared is the biggest thing we're dealing with. And so there's a couple of ways we can write a quadratic function. The first one we're going to chat about today, which I'll admit has the most work to it, is standard form. I should have said that after we did it. But standard form occurs when we've got y equals or f of x equals ax squared plus bx plus c. It's going to look just like what you see up here in the two examples above. Okay? So like, for instance, on number 3, our a value would be 16. Our b value would be negative 8. C value would be 1. Okay, what do I need to know this ABC thing for? It's a legit question. As we're graphing these, we're always going to be seeing these curves, not absolute value functions, not V's. We got to get curvy now, people. We got to get curvy, more like a hill or a valley, okay? And so what's going to happen is there's going to be some clues that each one of these values can give us. Okay, so since a is first, we'll chat a first. If a is greater than 0, okay, it's positive, your graph is going to open up. So it's going to go just like that. Your vertex is going to be the lowest point. Okay? The center of your graph is going to be down here at the bottom. The y-coordinate of the vertex is the minimum value of the function, which makes sense because if the y-coordinate of this is at the very bottom, it's going to be the smallest or the minimum value. But again, y value, they're not interchangeable with y and x. X has a different function here, which we'll get to shortly. If a is less than 0, though, if a is negative, the graph opens down. There's our hill. And your vertex is going to be the highest point. So we're on top of the mountain. The y-coordinate of the vertex in this case is the maximum value of the function. What we'll do as we're learning through this is we'll use these in applications. Businesses use things with quadratics, believe it or not, to figure out how much can I charge for something. You know, depending on how much I charge, how many sales am I going to gain or lose, and they can maximize their profits by using math, okay? So not just to throw it out there, waste your time, it actually has some applications that we're going to be dealing with. So you're like, okay, a value, got it. Next little piece of the puzzle, okay? There's going to be this line that goes down the middle of your graph. Okay, where if I were to take my graph and have it on a piece of paper and I'd fold it along that dotted line that goes right down the middle through my vertex, I'd see the exact same things on both sides. Okay, maybe if you've taken an art class or something, you talk about symmetry. That's what this is going to be. Our axis of symmetry, I'm going to give you a formula for it, and I'm going to kind of do a little verbal here. So it's negative b, or the opposite of b, over 2a. Okay? So this is, I'll give you the big math term that goes with it. This is called the vertical line of reflection. Because again, if I have a parabola and I fold it, okay, line's going up and down, it's vertical, and it's reflecting the exact same thing on both sides, like a mirror would. So, that's where that comes from. So, what does this axis of symmetry do? Well, let me give you one other little bit of info. This is also the x value of your vertex. This is how I can mathematically start to figure out, hey, where's that center point? Where's my minimum or maximum? Because I can graph off of it. I can get information from it. There's a lot of things I can do with it. So I'm kind of getting a 2-for-1 here. So speaking of that, my vertex, that's going to be the center of our parabola, like dead center. Not a little off to either side or anything like that. It's symmetrical on both sides. And I'm actually going to add that here, because when we start looking at charts, you're going to get to see this. Once you know where the vertex is, you will see the symmetry. Graphically, chart, whatever it happens to be. And so that's why we got to make sure that we get the vertex in the right place. Because if we don't, then we're not going to be finding much. So notice, when we did axis of symmetry, and now we're doing this vertex finder recipe, it's the exact same recipe for both because you're finding the same thing. So, if that's how I find x every single time that we're in standard form, to find a vertex, it's a point. To have a point, you got to have x and y. So to figure out what y is then, all we're going to do is substitute the x value into the expression once we find it. It's straight substitution. There's some ways we can make the substitution go really fast, though. We're going to learn about that stuff as we go here. This first section of this unit is going to be such a nice thing to just guide us for a bunch of things. If, again, we're into it and we're immersing ourselves in it so we actually learn how the pieces work. So how does this go? if I want to know where the vertex is in this example, okay, first things first, remember up here, a in front of x squared, b in front of x, c is our constant that doesn't have a variable. So here, my number in front of x squared is 1. My number in front of x is 1. My constant value is -6. So, axis of symmetry. Okay, here we go. X equals the opposite of b, -1, over 2 times a. Simplify the fraction that's there. -1 over 2. Okay? So the line, x equals -1/2, is going right through the middle of this parabola. And we're actually going to visually look at it in a minute, but we're going to find the vertex first. So to find the vertex, y, f of x, same thing. We're going to substitute that -1/2 in everywhere that there's an x. And me, personally, I don't want to deal with that on my own. I'm going to give myself some assistance here. You're like, okay, Hardy, can I use the decimal or math enter, or should I use the fraction? It depends. I'm okay with both, but usually when you look at my answers, you're probably going to see the fraction. But if you have the decimal equivalent, like I said, I won't jump up and down and yell. Just like on the test yesterday, I can't remember which question it was, but one of them was like 727 over 5 was the answer, or it was like 142.4 is a decimal. I took them both. I don't care. It's the same thing. If you're graphing, though, I use the decimals because it's going to be easier to comprehend up here how I'm going to graph that. But just to let you visually see something for a sec here, I'm just going to type this in quick, and I want you to be able to look at the graph. And here's what I want you to kind of notice. It's not a perfect science, but it can kind of give you an idea. I look here, I'm like, okay, here's my bottom, here's my minimum. And if I follow that up to the x-axis, it looks like it's between 0 and -1, about -1/2. If I look where the y value is, 1, 2, 3, 4, 5, 6, and a little bit more, -6.25. I'm going to show you ways to do that with the calculator as well and find different pieces that you need. But understanding where it comes from is key before we get to all the calculator stuff. Okay. Pause. Questions on what we've done so far with the axis of symmetry or finding your vertex, because that's like a non-negotiable. We got to have that down first. Yes. Okay. Let's build a little. So when we get over here, and I just offer your patience there. So, okay, complete the following questions about the graph. So we got a picture this time. We don't have an equation yet. Okay. So I look and I'm like, okay, I mean, the vertex I know is right in the center. That looks like the very bottom, and it's at a coordinate point, which is nice. So I can rack that out pretty easy. Did I unfreeze? Duh. People at home, great. People here, not so much. Vertex, bottom of your graph. Thank you. Left 2. Down 3. Okay, I've got that. That's going to be some important info here in a minute. But we'll get there. My axis of symmetry goes right through the center. Is always x equals and is always the same as the x value of your vertex. Every time. Without exception. The rest of them I think I can figure out. This is opening up. There it goes. My vertex is at the bottom, so it's a minimum When you talk about maximum or minimum, again, you're talking about the y value at the vertex. So my minimum value here would be -3. Because that's as low as I go. And your y-intercept, where I'm crossing the y-axis, occurs when x equals 0, hence why we're on the y-axis, is at 0, 1. Not 1, that's a number. Not y equals 1, that's a horizontal line. Intercepts are always coordinates, and with a y-intercept, that x-coordinate will always be 0. But here comes the interesting question. How am I going to figure out the equation for this? Because I don't have a lot of information quite yet. And my answer to you is going to be hang tight, because I'm not going to introduce it quite yet, because there's going to be an easier way to do it momentarily. So hold tight. Later information. So I'm going to freeze frame for a moment. Number 5, answer the questions as best you can. There is one twist in there. We'll see if you catch it or not. And we'll kind of see where we're going here. The only twist that got thrown in there was that this time you were asked to find the x-intercept instead of the y-intercepts, I should say. So where's it crossing the x-axis, which occurs when y equals 0? Crosses at 1, crosses at 5, but again, they're coordinate points, and your x-intercepts always have a y value of 0. So little details, again, that seem small until we get to a summative that we forget that, and then it's like -1/2, -1/2. You're like, crap. But again, we're holding off on the equation because I want to send you through the way that we're going to use once we see it. So I'm not going to go through this with standard form because it'll just make life more difficult. Okay? How do we figure out if a function is a quadratic? Okay. It has a degree of 2. The highest exponent that you see is 2. If it's 1, it's linear. If it's 3, it's cubic. We'll do that down the road. But that's all we're looking for, is something with x squared. And then if it has a max or a min, maximum, oops, I almost did that backwards. You have a negative a value. So like if I was looking at an equation that said y equals -4x squared, it's opening down, or a minimum value, when you have a positive a value, because it's going to open up, versus when it's negative, we're going to open down. Kind of look at it that way. So here's another one of those things where I'm going to introduce a couple of things, but I also want to simplify it as we go. So here's my thing. When we get to the calculator here in a moment, okay, you can always get to the table by just hitting second and graph, anything that we've got in here. So like that example I had up before, if I hit second and graph, we've seen this before, there's all my numbers, okay? But when you're looking, there's a lot of stuff that you can get just from a table. So if you find when y equals 0, those are x-intercepts. If you can find where x equals 0, You found the y-intercept. The vertex to me is where I'm in disagreement on how to tackle it. Yes, it means that your vertex is somewhere in here because, again, you've got all these repeating values that are going on around it, and it gives you an idea, hey, there's the symmetry. There's 2, there's 0. If I saw the next one on this, I'd see -4. If you can visually see the symmetry, you know you have the vertex in the right place. Okay, there's ways to make that a little bit easier, though, which is what we're going to discuss now. So, again, just one other reminder. If you're looking at one of these in the calculator, if you hit trace and 0, if x is 0, there's where your y-intercept is. But there's an easier, again, or you can just substitute 0 for x and just solve the equation. I know some of you are much more algebra-based than you are calculator-based, and there's nothing wrong with that. So I always want to try and give you options both ways as we're doing these to make life as simple as we can. So I have, can I get to that? I can. We're gonna get to vertex. Okay, we're not gonna get all the way through the notes, but I'm gonna get to where I was hoping to. So cool. Okay. I'm gonna go calculator heavy for a moment, maybe. We'll see. So all the, holy cow, Hardy, how many questions you got there? Like 8 for each of these, but watch us whip through them. So, before I go to my calculator, I'm going to see how many of these questions we can do without it. So I look through here. Be careful, because remember, standard form, I'm just going to jot it up here at the top quick. Do not just go left to right on these. My a value is not 5. My a value is the number in front of x squared. So my a value is -1. My b value is the number in front of x. That's 4. And my c value is the constant. So don't get sucked in. With that in mind, without looking at a picture even, is this parabola going to open up or down? Down. Because again, your a value is negative. Parabola heading down. So if my parabola is heading down, is my vertex going to be a max or a min? Vertex is at the top, it's going to be a max. Vertex is at the bottom, it's going to be a min. So you can see how these two things come together. Once I know what direction it goes, I know what the next thing is. Now, my axis of symmetry, I got to do a little work. I got to do my little formula here. So I've got to do the opposite of b over 2 times a. And again, if you've got to have your notes out for these formulas and stuff at the first, that's not a problem. So -4 divided by -2 is 2. X equals 2, because this is a line. So I have my axis of symmetry using my little formula. Which leads me to the next step. My vertex, I know the x value because these are the same. But now I got to go back in. If I want to do it with a calculator, I can. It don't matter. I'm going to plug in that 2 everywhere that there's an x. Now, some of you may be wondering right now, well, wait a minute, Hardy. Couldn't I just go to y equals, here's where the tech part can come in, and do the chart. And once I know what the x value of my vertex is, just grab it from the calculator. You can. That's kind of cool. There's a lot more cool things once we get to that. Here's the other thing that I can double check with knowing my vertex now. Check this out. If I have my vertex in the middle of my chart, look at the numbers as you go out. 8, 8, 5, 5, 0, 0, negative 7, negative 7, negative 16, negative 16. It's symmetry. It's the exact same numbers above and below. That lets me know that I got the vertex right. If I put this vertex that I think it is in the middle of my screen, and I'm seeing all these weird numbers above and below, some went cuckoo. Maybe I forgot to do a negative or something like that. But here's the other nice thing. I can start stripping this other information from here too. X-intercepts. Do I see any places where y equals 0? If I do, that's an x-intercept. I might see more than one. That's an x-intercept. I'm going to show you other ways as we go through the lesson over a couple of days how you can even find fractional or decimal ones if you need to. Now, y-intercept, okay. That occurs when x equals 0. There it is, 0, 5. Okay, what if I didn't figure that out with a calculator or something? I just plug in 0 for the x's. 5 plus 0 minus 0. It's 5. Okay, I've got that. But here's the part that I like best. Domain and range. This parabola is opening down forever to the left and down forever opening to the right. Here's your free square, people. It doesn't matter if it opens up or down, if it's skinny, if it's wide, if it's shifted, doesn't matter. Your domain on a quadratic is infinite, always. Don't even have to think about it. You don't even have to look at the equation. It's a quadratic. Let's rock and roll. My range, remember, goes from the bottom, down forever, to the top. Now, I could look at my graph and try and count up. The max is the y value of my vertex. These two numbers, okay, are always going to match each other. There are patterns and combinations everywhere with this if we give it a shot. So, one more thing I want you to play with for a minute. Yes, I'm going to let you play this time. I want you to play with number 7. Hopefully I'll remember to unfreeze again here in a minute. Use your noggin, use the notes, use number 6, use the calculator, whatever you got to do. Sure. Let me get this. Watching me go light speed here. This is what happens when you've been doing this for a while. Get a couple of things up here, and we'll kind of see where everybody's at. Look at our picture and our chart as well. And start trying to find those connections as you're working through these. Because that's going to be the key to making sure that we've got everybody in the right spot with stuff. All right, that's what we're going to do. Okay. Undo that. And again, before those first 3 questions, we should be able to knock out before we even ponder going to the calculator. Once we get past there, yeah, I could stick -2 in for x to get the y value of my vertex. That's absolutely true. Okay, I could stick in 0 for x to get my y-intercept. Not a problem. X-intercept, well, I'm going to say it. You could factor to get it if you needed to. But once you know what that vertex is, if you've got this in the calculator, again, center yourself up. You can move your table up and down. And if you see symmetry, you know you're in the right spot. And also, more times than not, don't disappear. Your x and y intercepts are going to be right there for you on the screen. Find y equals 0, there's your x-intercept. Find 0 for x, there's your y-intercept. Domain, I don't even have to think. I don't even have to know what the problem is. And then range, we're going from your min and the max value of your vertex, in this case the min, bottom 0 to top. Not infinity to 0. We're not going top to bottom. Order matters. Always bottom to top. So that's where I'm going to stop instead of trying to press my way into vertex form when your brains are probably getting near the end of me with this anyway. So here's what I need you to do. This is going to be simple. This keeps life simple for everybody. In the practice, page 1. That's as much as we got. So that's what we're going to do. So page 1 it is. 1 through 8. You're like, Hardy, do I need to do them all? Yes. Yes, you do. Okay? Because if we get the basics locked in, tomorrow, when I show you the easier form of this instead of standard form, and we start turning it into equations, you're going to have that background stuff ready to make this simple. Because if none of it goes into your brain before tomorrow, you're going to be back at step 1, and now I'm going to be throwing stuff onto you, and it can get overwhelming. And I don't want that. I definitely don't want that. So just use your notes to kind of play through these, and then tomorrow we'll start to add some even